In our solar system, comets were part of what nature didn't clean up after the solar system was formed from a swirling disk of gas and dust that we call the solar nebula. As this nebula of gas and dust, swirling around the sun, cooled down, it formed small rocks, or planetesimals, which then gathered together to make bigger rocks. These ended up forming the planets and moons. Comets are the leftovers. You can think of them as bits of cookie dough left in the bowl when you're done making cookies. Now, comets have water in them. Water is made from just two elements, hydrogen and oxygen. The gases hydrogen and oxygen, as well as water vapor, were probably all present in the solar nebula. Now, you can't buy interplanetary dust at the store, so we have to use sand or dirt in its place. Sand and dirt have the minerals and the simple compounds that are found in comets, but dirt also contains bacteria and mold, which are not found in comets. These living things have been created over the eons since the Earth was formed. Organic material means anything made up of carbon, hydrogen, nitrogen, and oxygen. Things like sugar, alcohol, and methane are all organic compounds. All living things are also made mostly of these four substances. Scientists have discovered that our Milky Way galaxy actually contains a very simple kind of sugar that probably existed before the planets were formed. So corn syrup, or soda, represents the simple organic compounds that were probably present in the solar nebula, and these helped form life later on. Ammonia, the same compound we use to clean windows, is another organic compound that existed in the solar nebula. The atmospheres of giant planets like Jupiter and Saturn contain large amounts of ammonia. Whew, that is one stinky comet. And last but not least is dry ice, or frozen carbon dioxide. This is the same gas that makes the bubbles in the soda pop. Most of what the atmosphere of Mars is made up of is carbon dioxide. Now, when a comet is far from the sun, its carbon dioxide is frozen like this into dry ice. So we're going to put this dry ice inside of a couple of plastic bags and crush it. We crush the dry ice so that it'll mix with the water, dirt, and other organic materials. All the ingredients in the original solar nebula were pretty evenly distributed. So, we crush the dry ice so it will mix with the water, dirt, and organic material. All the ingredients in the original solar nebula were pretty evenly mixed, so your comet's ingredients should be well mixed too, with no really big lumps. Woo! Now, Marty stirring this is like the rotation of the solar nebula that mixed the original batch of comets as it whirled through space. Mixing also brings all of the ingredients to the same temperature. Although this room and most of the ingredients we started with are at room temperature, the dry ice is about 79 degrees below 0 Celsius. That's 110 degrees below 0 Fahrenheit. Really, really cold. The dry ice cools all the other ingredients until they're frozen solid. In space, real comets are usually so far away from the sun that they're even colder than this. Now I'm going to hold the bag while Marnie presses this mixture into a ball. All right, let's see. Oh, voila, a comet. Now don't worry if your comet doesn't look round and smooth. Real comets aren't either. Comets orbit the sun and have a variety of different orbital periods, ranging from a few years to a few hundreds of thousands of years. Now, if a comet's orbit takes it close to the sunlight will heat it up, and the surface of the comet begins to change directly from a solid into a gas, forming a long gossamer tail. As it heats up, the ice that's holding it together disappears, and it will shed some of its material, leaving a trail of dust and small rocks in its wake.